something is from 0. When you deal with absolute value, or excuse me, rephrase that. Whenever you're measuring distances, your distance is always what? Positive. So, example, if I'm walking backwards 5 feet, I didn't go negative feet. I just went 5 feet that way. If you put your car in reverse and drive backwards, miles don't come off the odometer. It doesn't work. You have to legitimately crack open the what is it? The gauge. Yeah, sorry, I forgot what it's called up top. And then you have to go behind there and roll it back. There was a dealership in McHenry that got in trouble for that in the mid '80s. The guy had to go to jail. Yeah, right. So this Buick Encore only has 37,000 miles on it. It would probably have like 137. Back in those days, GM cars were pieces of junk, so they would do anything they could to try to resell them. Anyway, so absolute value, as we say, is shown by those vertical uprights. When you start thinking about graphing, I always like to go back to how you guys first learned how to graph just regular equations. We always learn how to graph via tables. Does that ring a bell? So what we did was we always picked easy values. We substituted into our function, and it spit out some y value. Your input, output. Okay? What we always did is our first set of table stuff. We always try to use numbers that were bounded around 0, around the origin, so you knew what was going around the where the axes intersect. So if I throw -2 in there, what's the absolute value of -2? 2. Absolute value of -1. What's the absolute value of 0? Absolute value of 1. And the absolute value of 2. Whew. Good work, ladies and gentlemen. That was tough. I know it's brutal. It's Wednesday. You guys are doing great. Okay. Pretty sure it's Wednesday. Yep, Wednesday. All right. So, guys, again, this goes back to plotting points. -2 and 2, -1 and 1, 0 and 0, 1 and 1, 2 and 2. If you connect those, you'll notice it creates a V. Okay? It does something like that. Now, with that, all absolute value graphs will look something like that. What happens then is that they just get moved around. Okay? There are certain rules that will occur with them. This is kind of one of the first times you guys are going to see something different, and I want to just kind of slowly piece it together. In this case here, this says y equals -2 times the absolute value of x. Okay? Now, when you have absolute value and something out in front of it, you always treat the absolute value like you would parentheses. That means your order of operations go with what's inside those absolute value stuff first, prior to your multiplication. Does that make sense? Do you guys vaguely remember those rules? That. Thank you. You treat the absolute value stuff inside the absolute value like you would parentheses when you have order of operation stuff. Okay, the absolute value is technically a working symbol, so it's kind of the same basic-ish idea. So if you go through your table again, that just means it's -2 times the absolute value of -2. Well, order of ops tell you what's the absolute value of -2? What's 2 times -2? -4. And so on and so on and so on. Okay? So if I go through that one, excuse me, absolute value of -1? 1. 1 times -2? Absolute value of 0? Oops. Wait, sorry. And it looks like that. I'm just going to skip around through this. Okay. Now notice what happens with the graph. It's upside down now. So we have, what was it, -2 and -4 to, oops, sorry, that was 3. Also, what are the slopes of those two lines? 2 and -2, isn't it? Oh, I wonder what's happening. What's the slope of those lines? 1 and -1. Oh, it's crazy. Math is mathy.
We're getting crazy.
I know. We gotta pace ourselves though. We don't want to go too crazy too fast. Why is he making fun of you?
I don't know.
Stop making fun of her. She hasn't done anything wrong yet. I've given her the benefit of the doubt for the first 15 minutes of class. After that, it's all over. So it gets us to something like this. This is going to be your introduction to what we call H and K. Don't you, Ed? H's and K's are things that go with graphs throughout all of Algebra 2 and pre-calc. When you think of your H values, H's move things horizontally. Horizontal. K values move them vertical, up and down. What? Horizontal and vertical. All right. What values go left and right on a graph? X's. Horizontal. Okay. What values go up and down? Y's. Vertical. What letter comes first in the alphabet? X or Y? X. What comes first in the alphabet? H or K? H. H's correspond with your X values. K's correspond with your Y values. What comes first in the alphabet? Sine or cosine? Cosine is going to correspond with your X. Sine is going to correspond with your Y. All right, what is tangent? Remember what tangent was last year in geometry? It's a ratio. I'll give you that. You're almost there. Okay, all right. So, for example, you're saying, I want to figure out what tangent theta is. It would be your opposite adjacent, right? Okay, so if by chance, if that's an ordered pair, if this point here is an ordered pair, right? So when I go left and right, what way are you moving? Horizontal, your X value, and your go up and down is your vertical, your Y value, right? So is it opposite the vertical? This is your horizontal, so is it tangent going to be Y over X?
Wow, guys.
What comes first in the alphabet, sine or cosine? Cosine. What comes first in the alphabet, X or Y?
X.
So we're going to be able to, sorry. Tangent's going to be equal sine over cosine.
Okay. It's pretty magic. Oh, it's just. It's not magic. Wow.
Now, granted, this is stuff that we're not going to worry about till end of January. So if you want to memorialize this and take a picture of it and send an alarm to go off like January 30th, and we'll be like, hey, look, we're kidding. Don't everybody do that at once.
If I do that?
Yeah, you should.
Okay.
Anyway, so what happens here is we're going to get these things what are called parent functions and shifted functions. Each parent function can be shifted. For example, what we have here for what we're going to call our parent function for absolute value, your parent function is that. Okay? the value of A out in front is your multiplier. The A value tells you what direction it's going to go. If your A values are positive, your B's are up. If the A values are negative, your B's are down. The A value also denotes slope. One of them will be positive, one will be negative. If they're up, the one on the right is the positive, the one on the left is the negative. If they're negative, it's just reversed. Okay? The H and the K then tells you where to start. The H and the K becomes what we call the vertex of the absolute value graph. All right? Dependent upon what the A value is, it opens up wider or more narrow. When we just did the absolute value, we had the 2 out in front, it was more narrow because your slope was steeper. If it's a smaller slope, like a 1/3, it'd be out wider because you up 1 over 3. Does that make sense? That's how that comes into play. So this absolute value stuff is actually very, very easy to do, and it's a nice, easy intro into what we call A, H, and K. Now, you've actually been doing this before with that. What is this? That's point slope form, isn't it? Now, this is a shift vertically, isn't it? The Y, vertical, and your X is a horizontal. It's stupid, I know, but it works, okay? Now, isn't M the multiplier?
Yeah.
The steeper it is, the higher the value of this so I can call it A. So this is the same thing as saying Y minus K equals A X minus H. Well, what do I do with the K? I just move it over. And it's the exact same thing. You guys have been doing this stuff all along. You just didn't realize this is what we were doing. Point slope form isn't as easy to use in this method, especially for Algebra 1 students or geometry or when we first get going, because 9 times out of 10 you want to do something with this K value by distributing. And that's just the weird thing. Now, the one thing you have to pay close attention to is how this is written out. X minus H plus K. That means your H and K value, those values themselves will wind up being where the origin of this occurs. So if I'm looking at the example I wrote there of Y equals 1/2 absolute value of X plus 2, all subtract 3, what is your H value? 2. Now if it was 2, it would be X minus 2. It's there. Good. When it has that minus the H, that means it's the opposite sign of what you think it is. The plus K is just whatever the sign is, okay? And that will hold true all throughout the entire school year when we deal with A, H's, and K's. The minus H shows up all the time, okay? And it's usually a plus K. Don't get me wrong, we get to conic sections, there'll be minus H's and minus K's, but by then you'll be like, oh. All right. So here, if I take this problem, actually, I think I already have it on the next slide. Nope, I don't. And I want to go ahead and work through how do I plot this. Well, the first thing you always want to do is identify what your A value is, what your H is, and what your K is. That way you know where to start. Okay. That's the easiest thing. Oh, if you need more graph paper, right, there's plenty of it in the back there too, but I think I've given you guys a lot. Okay. What's your value of A? 1/2. So is it going to be opening up or down? Up, good. So our A value is 1/2. What's your slope going to be? Or, remember you've got 1/2 this way, and what's the other one? Negative. Remember, because there's 2 of them, okay? There's 1 of each, all right? You're right, it's 1/2. What's your H value? And your K?
3.
Is it 3 or negative 3?
Negative.
It's negative 3. It's why? Because it's what? Oh, I thought I had it here. When it's a minus H, it's the opposite of the sign. When it's plus K, it is the sign. It's just one of those weird rules you get used to. Okay? So your H value is -2, your K value is -3, which means the origin of where this one starts at is at? Very good, very good. -2, -3. So I just plot it. I go to -2, -3, and I put a dot. And then once again, we know that this has to open upward because the A value is positive. So all I have to do is just start marking off points. I go up 1 over 2 to the right. And then I go up 1, left 2 to the left. Sure looks like a V to me. A absolute value. It's absolutely riveting. Let me clear my throat. What? It's a good song. Okay. Try another one. Bless you. Yep. And K is it's what it is. So here we've got we have the negative times the absolute value of x plus 2, all plus 3, which means what's your A value? Which direction is this going? Down. And your H and your K are? Good. And K is at positive 3. And then it's just time to hold up. Like I said, it's time to hold up. Case 3. So with any luck, your vertex, if you will, -2, 3. A value is -1, which means you have two slopes. You have -1 slope and you have a +1 slope. But remember, you're moving down. So if you do your negative slope first, then the positive slope just goes the other way. Yes. It is. It's very similar to a piecewise. Its domain, the domain is not restricted though. The domain for these things would be all real numbers. It is range restricted. In this case, the range would be all values that are less than or equal to 3. Does that make sense? This is a great question. So I was asking is this is kind of similar to a piecewise function, but in essence it is, but it is not domain restricted whatsoever. It has a range restriction. In this case, the range boundary would be that all values of y that are less than 3. Whereas the other one that we had here, it was all values of y that were greater than -3. And the domain would have been all real numbers. Yes. Yep. H is always the opposite. Whenever you see it written as that -h, it's always the opposite sign. K value is always the same sign. It's the rule for those. All right. I don't think I need to do another one. But we'll get to this eventually. What's the equation? Let's see if I can blow this up some. No, I'm not kidding.
Negative.
Well, I can blow this up some for you here. Let's see. It's right there.
Whoa.
Well, that makes it harder.
Okay. All right. Well, here, I'll zoom in for you. Oh, that didn't work. Did you guys not know you can do these things?
No.
So they zoom over here a little bit, but you zoom in a little bit more. Wait for right.
You're distracting me. I can't do that.
I didn't do anything.
You're distracting
You guys didn't know this stuff happened?
No. You do that like, don't know what you're doing. Just
I know.
My teacher can just put up the YouTube.
Yeah, like keep some reading in the first semester. My heart just pounds for this stuff. I don't. Horizontal. As far as you guys know these little tricks.
I think I forget to cut off the auto fan.
Anyway, where's your H and K? Your HK is at 3, 1. Okay, your H and K are at 3 and 1. So I always start by writing out what the rule is going to look like. So my H and K are at 3 and 1, and then I got to figure out the slope. Okay, so when you're going through the slopes, I just moved this, but I did have. Whenever I give you something like this, I will always. I'll figure out a way to show you guys what specific points that it's landed on. Whether I just darken it, I'll probably just darken in an extra set of points on there so that we can figure that out. That way, because sometimes when you draw stuff, it doesn't quite match up always perfectly. But if I look at this, we know that your A value is going to be a negative something, correct? Because if B is down, so we just have to count. Down 1 little, 2 little, 3 little spots. 1 little, 2 little, 3 little spots. So your slope is? Okay. Nice substitute in. Y equals -1 absolute value x minus 3 plus 1. Yeah, you don't have to put the 1 there. You can just write it as negative times the absolute value. That'd be fine. Yeah, if you guys want to just put the guys. You want to just put the negative in front of the absolute value symbol, that's absolutely fine as well. It means the same thing. I usually just write the -1 in, that way we know for certain that it's okay. Try one more. You will be victorious with this one.
I love that show.
What show?
Victorious.
There was a show called Victorious when we were a kid.
I've never heard of it. All I know is that my children don't watch that. I'm sure it's great.
It's very good.
Sounds awesome. My children like watching.
No.
My children just want to watch video compilations of fails. Like people falling off things. Yeah, that's what they do, like watching people get hit in the face. They like that. Slapstick humor. I mean, bless you. So we got A, H, and K again. Where's your vertex at? -1, -1, good. So our vertex at -1, -1. Wow. Guy takes a couple days off. No, he's just raising hell in here, I tell you. And then what's your slope? 2, so your E value is. So we get Y is 2. Now here's the thing. If you wanted to be rambunctious, how could you tell if you did this correctly? You could graph that, but why would I waste time regraphing it when I could use my calculator? I know, right? So, if you want to double check through, if you go to Y equals, I'm getting there. If you go to your Y equals tab, we want to put that function in. What I would do is obviously put in 2. Then we have to do alpha window, I think. Alpha window, option 1. So if you hit alpha window, enter, that gets you inside the absolute value. It just looks like little uprights. Then I would type in my x plus 1, and then I have to get outside of the absolute value, so I have to move to the right, and then I write minus 1, and then I'm going to graph it. Maybe, maybe not. Good times. Try those. Shouldn't take very long. Sure. I think there's like 3 or 4. Like 3 or 4 right before. These are absolute values are really nice. Is there enough graph paper back there? You need more. You don't need it after a while. This is the last run of